Welcome back to my YouTube channel. So recently, OpenAI just released the GPT 4.1 model secretly. It's a new model that features major improvements on coding, instruction following, and long context, plus the first ever Nano model in OpenAI. So it has three models here: GPT 4.1, GPT 4.1 mini, and GPT 4.1 Nano. The major thing is that it's supporting the large context windows, supporting up to 1 million tokens of context, and it has a refreshed knowledge cutoff of June 2024. So there are a few industry standard measures for the GPT 4.1 that is doing very well. It's on the coding, instruction following, and long context. For the coding, it's using the SWE-bench verified, improving by 21.4% over the GPT 4.0, and it's very cool. We will go through these three major benchmarks and to better understand what each benchmark is about. So what is SWE-bench verified? It's actually released by OpenAI with a human validated subset of SWE-bench. It's a human-validated subset of SWE that more reliably evaluates the AI models on solving the real-world software issues. You see, one of the most popular evaluation suites for software engineering is SWE-bench, a benchmark for evaluating large language models to solve real-world software issues sourced from GitHub. So basically, it gives agents a code repository, an issue description, and challenging them to generate a patch that solves the problem described by the issues. But why are they introducing a new SWE benchmark? So they point out that they identified three major areas for improvement. The first is that the unit tests used to evaluate the correctness of the solution are often overly specific and in some cases are even unrelated to the issue. This potentially causes correct solutions to be rejected. So the second one is that it has an issue description and leading to ambiguity on what the problem is and how it should be solved. Also, it's difficult to reliably set up the benchmark development environments for the agents, causing the unit tests to fail regardless of the solutions. So that's three major issues they find out from this. So the SWE-bench verified, they launched a human annotation campaign with professional software developers to screen each example of the SWE-bench test set. So it's a subset of the original test from SWE-bench consisting of 500 examples verified by human annotators. Let's go to the next, measurements, the instruction following. So it's the MultiChallenge benchmark. So it's a measurement of instruction following ability. So it got scores like 38.3%, a 10.5% increase over the GPT-4.0. So what exactly is this? Let's check out the MultiChallenge. So this dataset is a pioneering benchmark evaluating large language models on conducting multi-turn conversations. MultiChallenge identifies four categories. The four challenges are instruction retention, inference memory of user information, reliable version editing, and self-coherence. Okay, so next we're going to talk about the long context. On the Video-MME, so it's a benchmark for multimodal long context understanding. The GPT 4.1 sets a new state-of-the-art result, scoring 72.0% on the long, no subtitles category, a 6.7% improvement over the 4.0. The Video-MME, which is the first ever comprehensive evaluation benchmark of multimodal LLMs in video analysis. So this benchmark is very great if you are looking into a model that's specializing in the video analysis. And you can check this leaderboard to find out which models are performed the best. Basically, it stands out on the four key features. The first is the diversity in the video types, and it has the duration in temporal dimension. It has short, medium, and long videos from 11 seconds to 1 hour, and it has the breadth in data modalities, integrating multimodal inputs like weather to including the subtitles and audios. And then it has quality in annotations utilizing rigorous manual labeling by expert annotators. 900 videos with a total of 254 hours are manually selected and annotated. So by looking into the leaderboard, you can see that it has the model And the score on short video, medium video, and long video. So for the short video, it has less than 2 minutes, medium 4 to 15, and long video like 30 minutes to 60 minutes. So based on these durations, you can determine the most efficient models for your specific project. So that's very cool. So the GPT 4.1 mentioned that it dominates the long video form without the subtitles. So it reached to the 72%. It's really the number one compared to the 67.4 right now. And of course, the Gemini 1.5 Pro is, tested on 2024 June, almost a year ago. I'm interested to see the 2.5 Pro on this new leaderboard. So I think the important things about the new model is intelligence by latency curve among the GPT-4 family. So you can see from the picture that the GPT 4.1 mini is a significant leap in the small model among these three. It's almost double the intelligence than the GPT 4 mini, while only sacrificing a little bit latency here. The GPT 4.1 mini is very impressive model, and you see it says it matches or exceeds 4.0 in intelligence levels while reducing latency by nearly half and reducing cost by 83%. And also the GPT 4.1 Nano is the fast and the cheapest model available. It's a small size with 1 million token window. The most important thing about the pricing, the GPT 4.1 is 26% less expensive than the 4, and the important thing is that for the queries that repeatedly pass the same context, it has the prompt caching discount to 75% for these models. Meaning that if you have some queries, like in the same ongoing user multi-turn conversations, the same prompt will be discounted to 75% of that cost. Alright, so you can check the price here. So next, I'm going to show you where to interact with this new model. Since it only can be called on the API, there's one place you can try it in the playground. Okay, first you have to create a new secret key, like the API key. You give it a name, like GPT-4.1 test, maybe. So you select the project. I will do the default project and create the secret key. And so here's the playground. You can select the model here. You can try the Nano 4.1 and 4.1 mini. You can create tools or something. You can use the system message, add messages, and chat with it and see the response. Here you can try some examples. You can just pick the model and write a system prompt maybe. You create a system prompt like you are a helpful assistant and chat something like explain the concept of quantum entanglement in simple terms. You see I got the response here. So here you can tweak the temperature, the maximum tokens. I think it's just 16,000 there, but I'm sure that you can fit up 1 million tokens inside the API calls, so you can tweak those parameters. Alright, so next I'm going to walk you guys through the Colab tutorial for calling the API call. So first, we're going to install the package. And next, we're going to set up the API key. So you see there's a key here and paste your OpenAI key there. And then you click the access. Once you enable that, you can run this and you see, oh, the environment variable is set successfully. Open client initialized successfully. So you have the client OpenAI. That's the way to initialize the OpenAI client, right? Next, we're going to make an API call. We can define the messages here, like to set up the role as system. The content similar to in the playground is you are a helpful assistant. And also the role user content, explain the concept of the quantum entanglement in simple terms. Next, we just set up the model to use. So this time I'm going to use the 4.1. And this is the place to make the function call. And you put the model here, the messages here, and other parameters you can tweak about. Okay, let's run that. Sending the request to GPT 4.1 API response content. Quantum entanglement is a strange and fascinating idea from quantum physics. That's pretty nice. So thanks for watching and hope that is helpful. And if you enjoyed it, please don't forget to like and subscribe to support the channel. And I'll see you guys in the next video.